Hello everyone. In this lecture, we will be solving GATE 2000 previous year question based on priority scheduling that comes under CPU scheduling in operating system. Here we are given 5 processes along with their arrival time, burst time and priority associated with each process. Now here P2 process which has priority 0 is the highest priority process, and similarly the next highest priority process is P4, and similarly the least priority process is P5. So what we need to find out is we need to find out the average waiting time of all the processes by following preemptive priority scheduling algorithm. Now let's do the numerical. So now here this is the given question that we have, and now we have to first of all draw the Gantt chart of this. So as it has said that we have to apply preemptive priority scheduling. As you can see, the process having highest priority is this one, P2. This has the highest priority, right? And the process having the lowest priority is P5. Now, according to the priority scheduling algorithm, P2 has to occupy the CPU first. But because the arrival time of P2 is 5 milliseconds, so it cannot take the CPU currently. It can only take the CPU once it arrives the system, right? So till the time whatsoever process is present will execute, and when P2 will arrive, then it will take the CPU, right? So that is why it is also called as preemptive. Why it is preemptive? Until and unless it arrives, whatever processes which are already there in the system are going to execute. But as soon as P2 arrives, it is going to preempt the other processes which are in the memory, and it is going to take its place because it has the highest priority. Because in the question it is given that the process having 0 as the priority is the highest priority process, right? Now let's do it. So let's see which is the process which is available at the 0th millisecond. So we have with us only P1. So P1 is the only process which is available here, right? So obviously it is going to take the CPU here. Now, so P1 will occupy the CPU and it is going to run for how many seconds? Not 5 seconds, but here as you can see at the after 2 milliseconds, P4 process arrives. So obviously it is going to prevent P1. So now let's run P1 for only 2 milliseconds. So P1 will run for 2 milliseconds. So the remaining time here will be, so it has run for 2 milliseconds. So the remaining time is 9, right? Now who has arrived the system? P1 was already there, right? P1 was already there, but now P4 has also arrived, and out of P1 and P4 has highest priority. So because the priority given to is 1, which is greater than P1. So that is why now P4 is going to preempt this P1 and it is going to take the CPU. So now who is going to take the CPU? P4. Now again, how long is P4 going to run into the CPU? Until and unless the next higher priority comes, right? And next higher priority is of process P2, which will come at 5 milliseconds. So that is why it is going to run for next 3 milliseconds. So 2 plus 3 is 5. So the remaining time left here is 10 minus 3, 7. Now here we can see that already P1 is there, P4 is also there, but who has arrived? P2 has arrived, and we can see that the priority of P2 is highest among P1 and P4. So it is going to preempt. It is going to preempt this P4 and it is going to take the CPU. So now who is going to take the CPU? P2. And it is going to run for all its burst time. So the burst time of P2 is 28. So it is going to run throughout 28 milliseconds because it's the highest priority process. So now it is going to run for next 28 milliseconds. So 5 plus 28 is 33. Now as we can see here, this process has completed its execution. So P2 completed its execution, right? P2 is completed now. After that, so here the time left is 0. Okay. Now here when this is done, now after 33 milliseconds, because the highest arrival time of is of process P3, which is 12. Now after 33 milliseconds, all the processes have arrived this system. They are waiting in the CPU. So who is going to take their turn? So P1 is there, P3 is also there, P4 is there, and P5 is there. And now this is being done. So after this, who is the next highest priority process? P4 is the next highest priority process. So now P4 out of all these processes is going to preempt P2. So it is going to preempt not P2 because P2 has already executed, it has completed its execution. So now the turn is of P4. So now P4 will take the CPU and it is going to run for its complete remaining burst time. So the remaining time of P4 is now 7. So it is going to run for next 7 milliseconds. So 33 plus 7 is 40. So now it has also completed its execution, right? Now P4 is also completed. Okay. So P4 has also completed its execution. Now we are left with three processes, that is P1, P3 and P5. And out of P1, P3 and P5, the next highest priority process is P1, and P1 is left with how much burst time? 9. So next process which is going to take the CPU is P1 because it has the highest priority. So it is going to run for next 9 milliseconds. So 40 plus 9 is 49. So it is going to run for 49 till 9 milliseconds. And then the processes, so who has completed by this after this time? P1 has also completed its execution. So P1 has also completed the execution. Now, who is left? Only P3 and P5 is left. And out of P3 and P5, P3 has highest priority as compared to P5. So now P3 is going to take the CPU. So it is going to run for how many seconds? It is going to run for next 3 milliseconds. So 49 plus 3 is 49 plus 2. Sorry, this is the burst time. 49 plus 2 is 51. And we are just left with P5 now. So it is going to take the CPU next. Now the next process is, so who has completed? P3 has also completed the execution. Earlier P2 completed its execution, then P4 completed the execution, then P1, and now P3 has also completed the execution. So after this, we are just left with P5, and P5 is now going to run for next 16 milliseconds. So 51 plus 16 is 67, right? So this is the Gantt chart for preemptive priority scheduling, and we are calling it preemptive because if a lower priority process is running into the CPU, and if after some time the higher priority process comes, then it is going to preempt the lower priority process. Now, according to the question, what we need to find out is we have to find out the average waiting time. So let's find out the waiting time of all the processes. So let's find out the waiting time of, first of all, P1. So P1 completed, P1, like if I talk about this interval, can you see that? P1 has waited for 40 milliseconds, right? But in between, this P1 process was, because after this it is executing, right? This is the execution time. It does not come under waiting time. And after this, P1 is not at all there. So during this time, 0 to 2 millisecond, it was not waiting, but it was executing. So this time has to be negated. It has to be subtracted, and the arrival time is 0. So the waiting time of P1 is 38, right? So just be careful that in our waiting time, we have to subtract the arrival time and also the burst time. Then you get the actual waiting time, right? So from the waiting time, you have to subtract arrival time as well as the burst time. Now let's find out the waiting time of P2. Now coming to P2. So P2 got its turn on 5th millisecond, right? So it has to wait for 5 milliseconds, right? But when did it arrive? It arrived at 5 milliseconds. So that's why 5 minus 5 is 0. Now coming to P3. So what about P3? P3, as you can see from here, P3 got its turn at 49 milliseconds, right? But when did it arrive the system? It arrived the system at, you can see from here, it arrived the system at 12 milliseconds. So 49 minus 12. So you have to just subtract the arrival time because in that time it did not even arrive the system. So that is going to be 37. After that, P4, waiting time of P4 is So you can see from here, P4 got its turn at 33 milliseconds, right? So here you have to be very careful. But during this time, if you can see from here to here, this process was not waiting, but it was executing. So it was executing for 3 milliseconds. So you have to subtract the execution time as well as when did it arrive. P4 arrived at 2 milliseconds. So you have to also subtract the arrival time. So the remaining time here is 28. Now coming to P5. So P5 got its turn at 51 milliseconds. And here the arrival time is 9. So that is 42. Now let's find out the average turnaround time. So sorry, not average turnaround, average waiting time. So average waiting time is equal to waiting time of P1 plus P2 plus P3 plus P4 plus P5 upon the number of processes, that is 5. So here just add these terms. So it is 38 plus 0 plus 37 plus 28 plus 42 upon 5. And the sum is equal to 145 by 5. So the final answer here is, as you can see, it is 29. It is 29 milliseconds. So the answer is 29 milliseconds. So now let's go to the question and see the answer. So as you can see from here, the four options given to us are 29, 30, 31 and 32. Out of which, what is the correct answer? The correct answer is this 29, right? This is your correct answer. So I hope you understood the concept. So to get more updates, stay tuned to my channel. Thank you so much.